All right, 3-4. Today we're going to talk not about parallel lines, but about perpendicular lines. Perpendicular lines, remember, we use this upside down T to talk about perpendicular lines, and they meet at 90 degrees angles. So they meet at right angles. Perfect. Before we start talking about proving and applying theorems about perpendicular lines, I want you guys to review for a second number 1 and number 2. Number 1, it says solve each inequality. So remember, inequality means we have that less than or greater than sign. It says x minus 5 is less than 8. Well, to get x by itself, all we have to do is add 5 to both sides, just like we do in equations. So your final answer would be x is less than 13. So what this answer means is x could be anything smaller than 13. It could be 12, it could be 1, it could be 2. Anything smaller than 13 is an answer. Number 2 is a little bit harder. It's harder because we have an x and a y. Now there's 2 different ways you guys can do this. Some of you guys like substitution, and that is awesome. Other people like elimination. I'm going to show you elimination because I think this will help you out with the questions you'll see later on in the chapter. So elimination was when you line up the x's and the y's, and you eliminate one of the answer choices. Oh, actually, I don't want to do elimination for this one. I'm sorry. We'll do substitution, and then I'll show you elimination later. Substitution's easier because we already have solved one variable close to being done, right? If we divide both sides by 6, y is going to equal, I think it's going to equal 15, but I could be wrong. Okay, 90 divided by 6. Yeah, I was right, 15. Okay, now that you have y equals 15, you can then plug in afterwards. That's step 2. So for this equation, 8 times 15 minus 3x is going to equal 90. Now you guys can solve for x. So make sure you know how to solve for x. I'll check this tomorrow. Okay, first thing we're going to do today is we're going to talk about distance from a point to a line. Perpendicular bisector. Perpendicular means meets at 90 degrees, right? And bisector, the term bisector means it's something that cuts in half. Cuts something in half. Something in half. Hello. Okay. Into 2 congruent pieces, right? Okay, so perpendicular bisector is something you should know by now. We're going to use that today, not so much, but later on in the quarter. So again, perpendicular bisector as a picture, if I wanted to say that AB is the perpendicular bisector of CD, that means that it's going to meet at 90 degrees, and it's going to cut CD into 2 congruent pieces. So that's how I can say AB is the perpendicular bisector. And notice AB isn't being cut in half necessarily. Okay, perpendicular bisector, important. Distance from a point to a line. If I tell you for number 3 to name the shortest segment from point A to this line, it's always going to be a perpendicular line. So I would write down that shortest segment, shortest line, is always perpendicular. So if I ask you to name the shortest segment, all you have to do is look for the perpendicular line, and that's going to be AP. So this is the shortest line to line BC. Okay, and that's going to help us for number 4, where it says write and solve an inequality for x. Okay, so we need to solve for x. Well, we already said that this is the shortest line. So that means that this TA is shorter, or AP is shorter or less than AC. So since we know something about those lines, we could say we can plug in. So I know AP is 12 long, and I know AC is x minus 8. It wouldn't help us to talk about this other line, these other lines, because they didn't tell us anything about it. Now all we have to do is solve, much like we did up here for number 1. So I'm going to add an 8 to both sides. And now this inequality says that 20 is less than x. And unfortunately, we don't like it this way. In math, we like to have the x on the left-hand side. So when I switch it, notice I'm going to switch the inequality. So now I'm going to say x is greater than 20. These 2 statements are the same. They're the same answer, but x needs to be on your left-hand side. Okay, so you guys are going to try 5 and 6, and I'm going to check that tomorrow or Monday in class. And then we're also going to do example 2. We're going to fill this in tomorrow or in class as well. Okay, so let's get down to number 7. Next page on your notes. We're going to do some solving, and this is where we can use elimination. So bear with me, please, and I promise you it gets easier. Okay, number 7, it says in the diagram L is perpendicular to M. So that means that this line meets this line at 90-degree angle. It says find x and y. So again, this is a hard one because we have two variables. But, and remember, when we have two variables, we did this in class one day. When we have two variables, that means we need to have two equations. You cannot solve if you don't have two equations. Okay, so what are the easiest equations I could do? A lot of people like to add these up. They like to say 4x and 11x is 15x, and 10y and 5y is 15y. But then they get stuck. Or what do I do after that, right? So don't do that. We need to have two equations. Well, I already told you, since it's perpendicular, that they meet at right angles. So I could say that this 11x plus 5y equals 90 degrees. And since it's also perpendicular, this is also 90 degrees, right? These are a linear pair, so they add up to be 180, so they're both 90 degrees. So I could also say that 4x plus 10y equals 90. Okay, now I want to eliminate one of my variables, and I think that eliminating the y would be the easiest. So if I multiply this top one by a negative 2, then I would get negative 22x minus 10y equals, negative 180. I was multiplying every single thing on the top by negative 2. I'm going to keep this bottom equation exactly the same. So 4x plus 10y equals 90. And now I'm going to solve. So negative 22 plus 4, that's going to be negative 18x. These are going to cancel out. And let's see, negative 180 divided plus 90 is going to be negative 90. And now I'm going to divide both sides by negative 18. And I'm going to get that x equals, let's see, 90, divided by 18, 5. And we're not done. So we found x. X is 5. Now what we can do is we can plug in 5 into any of these equations, and it should, we could figure out what y is. So second part, I'm going to do it over here. I'm going to take this one because it's smaller and it looks simpler to me. So 4 times 5, I plugged in x for my, 5 for my x, plus 10y equals 90. Now I only have one variable, so I just need one equation to solve, and that's a plus sign. Okay, so 4 times 5 is 20. I'm going to subtract that 20 from both sides, and I'm going to get 10y equals 70. And then I'm going to divide both sides by 10, and I'm going to get y equals 7. Again, just like you did in Algebra 1 last year, if you wanted to check your work, all you would have to do is plug it into both equations, both the x and the y, and if they equal 90 degrees, then you did your answer correctly. All right, so you guys are going to try to do number 8, and I'm going to check that in class. And then the last thing we're going to do in this video, we'll do the proof in class. Don't worry about that. Example 3, proving properties of lines. So it says for number 9, determine if there's enough information given in the diagram to prove each statement. Okay, so the first one is angle 3 is congruent to angle 4. Now, looking at this picture, I know it looks like angle 3 is congruent to angle 4, but I want you to be sure. I want you to prove it to me. Like there's no doubt. It absolutely is true. So angle 3 and angle 4, to me, they look like corresponding angles. But we need to have parallel lines, right? So that's what we're going to ask ourselves. Are these lines parallel? And I promise you this relates to perpendicular lines. I promise. Let's see. Well, here we have right angles. So that means that, let's call these A, B, C, and we'll call this T for transversal. Okay, so if you notice, C is perpendicular to T, and line B is also perpendicular to T. These are same side, these right angles, are they same side interior angles? Yes. Okay, so since we have same side interior angles, we know that same side interior angles must add up to equal 180 degrees. So 90 plus 90, does that equal 180? Yes, it does. So since these add up to be 180, by the converse of same side interior angles, we know that B has to be parallel to C. That says interior. Okay, so now that I know for sure, without a doubt, that B is parallel to C, I can put that in my picture because I'm certain now. There's no doubt. These have to be parallel to each other. Now that they're parallel to each other, now I can say that angle 3 and angle 4 are corresponding angles. And so yes, true. That is enough information. Okay, that's kind of the process I want you guys to do. This is a little tricky. I want you to see if you can maybe do, let's see if you can do D, and then we'll talk about B and C in class. All right, fun fact of the video. Did you know that one out of every 8 boxes of cereal that is sold in the United States is Cheerios? Very interesting. Have a great, great day. And today we talked about perpendicular lines. Again, finish those problems, please. Try to do the reflection, and we will talk about the rest in class. Thank you.